Welcome to today's session. We'll be introducing you to Computer Science 2B, which is Introduction to Computer Networking. So basically, you're going to understand what is really going on, what's the behind the scenes of how the internet works when you're searching on, or when you're searching or going to a website, all those things, you get to understand what's really going on. So let's begin. So what is the internet? So the internet can be viewed in terms of two ways, right? So the internet can be viewed in terms of two ways. The first way you can you can view or describe the internet would be using the nuts and bolts description, right? Or approach. So this is just a different way of thinking about the internet. So in this way, we use nuts and bolts just basically mean hardware and the software involved in part of the involved in the internet, right? So this is the first way you can describe what the internet is. So we're gonna start with that, and then a services infrastructure approach or description. We'll get to that in the next video. There's a lot to there's a lot to unpack. So the internet you can basically view it as just a network of networks, right? So what is a network? A network is basically what we can call a network, a collection of let me just say interconnected devices, right? That send and receive data from each other, right? So a network is basically a collection of computers, right? It's just a collection of computers. As you can see, we have this computer, we have another computer there, we have another computer. They're all connected to the internet, right? So it's just a connection of when these computers are connected to with other devices, right? So I'll just say, let me just say a collection of, let me just say, put it this way, a collection of computers and other devices, right? That receive send and receive data to and from each other. So they said anything that you'd call or that you would regard as a network is when you have a collection of computers, right? And this is just the general purpose computers like your laptop or any computer and other devices. These other devices are just devices that help facilitate this this they help facilitate the internet, right? For us to be able to have the internet. It's like someone offering a helping hand. So that's what those other devices are for. It's just to offer a helping hand for us to establish what the internet is. So this is remember we're focusing on the nuts and bolts description, right? Which is just interconnected devices. We can see that the computers are connected to each other, forming what we call a network. So the internet is just like, so the internet, you can view it as like this one big collection of computers connected to each other. That's pretty much what it is. So now a question of, you might have a question on how do if we have what we call a network and computers are connected to each other, how do they send data and things like that? So when it comes to sending data, a network, right? A network is usually connected. It's usually connected by wires, right? So there's there's those wires that connect that help you connect to the internet, right? So that network it usually has those wires, right? So in this case, you can view like those wires as like these lines or this no, it's not really lines, but this metal straight thing. You can view that as like the wires that help us to connect and facilitate what we call the internet, right? So the network is usually connected by wires. And when it's connected by wires, you might ask yourself, how does how does it send the data, right? So data is the bits of data, right? Let me just say bits. And remember, bits is just binary digits. So the bits of data are sent are sent the bits of data, right? When you are sending, so when let's say you are sending some piece of data, right, or some information to someone, maybe you're sending them an image, right? So remember everything, but under the hood, it eventually is eventually stored as binary digits, which is just bits, right? So that's why I'm saying of bits of data are sent via the wires, right? So those bits of data travel via the wires using what we call electromagnetic waves. So they use electromagnetic waves to send those bits of data through wires. So this is there's sort of like three ways you can connect to the internet. It's through wires or cables, whatever terminology you want to use. So we are discussing the first approach. So if it's connected by wires, binary, which is binary digits. So these binary digits of data are sent via wires using what we call electromagnetic waves. So what happens when you are not using this approach of connecting with wires? Let's say it's wireless, right? If you remember the Wi-Fi, right? So Wi-Fi, you remember Wi-Fi is wireless, right? So Wi-Fi and other other means of connecting to the internet, but then I'm just going to use Wi-Fi, which is like a simple example to make. So with Wi-Fi, it uses what we call radio waves. So it sends data, the bits of data using radio waves. So sends bits of data using what we call radio waves. And then we have the last thing. So when it comes to Wi-Fi, it's usually it's usually like short range, right? So we'll get into the more details of the different, you know, terminology behind it. So in this case, with this Wi-Fi, we can view it as like being in your local area, right? So it's like it's within the house, within the building, right? So what about those long distance connections, right? So for example, let's say you have your MTN SIM card, right? So how does that connect to the internet? You don't have an MTN router, right? I'm talking for those who have MTN SIM cards, or can be Vodacom, doesn't matter as long as it's a SIM card. So if you have that SIM card, you might ask yourself, how does it connect if it's on a very long if it's on a long range. This is the radio waves could be used to connect when it's in a short range, right? So what about the long range? So the long range, it uses what we call um it sends light waves, right, through glass filaments. So that's the approach that it would use to to connect and send data wirelessly in longer distances or a longer range. So that's pretty much a bit of an introduction of what we're talking about, right? Let's just continue. So as I said, the nuts and bolts description, it basically means that we are referring to the actual software and hardware components. Components just means parts. So those hardware and software parts that make up the internet, that's what are they? So there's hardware and software components could be, for example, computing devices, right? So computing devices, primarily there were traditional devices such as desktop PCs, Linux workstations, and servers, right? So originally, when the internet started, it usually it was comprised of desktop PCs, Linux workstation, and servers. Primarily, that was like the starting point, right? And then nowadays we have what we call non-traditional devices such as your laptops and gaming consoles, right? There is more examples. You can check the textbook for more examples. The non-traditional and traditional devices, right? So meaning it means your PCs, your laptops, your gaming consoles, they are what we call hosts or end systems, right? So I would say it is called hosts or end systems, right? But then for the host and end systems, these refer to the general, I would say the general purpose computers, right? So the actual computers themselves, right? So a fully functional computer, we would call that a host. So imagine, and if you can try to link this, a host, remember, when you go to a party, a person hosts a party. The host is the person who's facilitating that activity, right? So these hosts or end systems are just general purpose computers, right? Basically, you would say it's like the complete thing, right? So if it's not complete, or the other things like software and all the other things that help us to connect to the internet, those are called what, nodes, right? They are called nodes, but then when they are complete and like general purpose computers and gaming consoles, right? So would now call them hosts or end systems. You can choose any term you want to use there. So that's pretty much it. And then, okay, so we have the end systems, right? Are connected by communication links and packet switches, right? So these end systems, what connects them? So if you go back to these end systems, these computers, right? So what connects them? So we need to have the right terminology for that. So there's pathways or paths, we call them communication links. So the communication links could be cables, right? Your wires, your coaxial cable, copper wire, etc. And then that's what we call communication links, right? And then each communication link uh, can transmit or send the data at different rates or speed, if you want to put it in that way. And this speed or the rate at which it transmits or send the data is called transmission rate. So transmission rate, this is basically the rate at which the bits of data are being sent over over the network, right? So that's over that network that we have, over the computers and the collection of computers and other devices. We call that the transmission rate, the rate at which you are transmitting or sending the data or the bits of data. So we have that. And then the transmission rates, right? They are measured using bits per second, right? So for example, if I'm transmitting, so bits per second, right? It's like you can imagine your Wi-Fi, right? So if you have a Wi-Fi when they tell you like the Wi-Fi is 1 gigabits per second, right? 1 gigabits per second. So that's what we mean. It's measured in that way. So remember, everything is in a computer is by default zeros and ones, which we call binary digits, or in short bits. So the the measuring unit we use for the rate at which the transmission rate is bits per second. You can have kilobits, so there's many. You can have kilobits, you can have megabits, you can have gigabits, and then you can have terabits, etc. Right? Which is the rate at which the bits are being sent per second, right? So at each second, how many bits of data am I sending? The higher the number, the quicker the information will be received by the user, right? Or the client. So we call the person who's using those services a client, right? And then the services we're using, we call that a server. So we'll get to those terms when you start coding. So when end systems send the data to each other, they send it in the form of what is called packets. So what is a packet? So what happens is your data, right? So let me use draw.io. So what happens is when you send data on the internet to somebody else, it gets it gets it gets the what's that term? It gets, so let's say you have this. Let me make a very simple example, right? Let me make a very simple example. So we have this, right? And then let's say I'm trying to send this message, right? Or maybe it's not just a message, it's literally a paragraph. Let's say, for example, hey, how are you doing, right? Let's say I'm just communicating with someone on a social media app like Instagram, Twitter, etc. So let's say this is the message you want to send, right? So remember, this is going to be converted to bits, right? Binary digits, which is zeros and ones, which is the language of the computer, right? So when it's converted to the language of the computer, what happens is in order for you to send the piece of data, this is a piece of data, there needs to be two things, right? We need to have this person here who's sending the data and the recipient who's receiving the data, right? So in simple terms, we would call this recipient, the person who's receiving the data, a client. And then the thing that's sending the data, we call that a server, right? It's in simple examples like this. So we have the person sending, which is the server, sending to the client. So we're sending this information to the client. What happens is that in order for this information to be sent, right, there's a rule that must be, or there's an approach that's taken to send in order to send this thing. It gets split up into what we call packets, right? Basically, you split it up into small segments or pieces, right? So you split up the data segments, into segments or just pieces, right? Into small pieces. You can imagine you can imagine it's a pizza, right? You cut the pizza into small pieces, right? And then each piece gets sent independently through to that person, right? So you can view it in that way. So we have this piece of data, right? So we have this text. It gets split up into what we call packets, right? Or segments or whatever the right terminology is packets, but then I'm using the word segments and pieces so that you get to understand what's going on. So it gets split up into what we call packets, right? So these packets, it's basically you cut the message into smaller chunks, right? Yeah, there's another term for it. You can use chunks. You cut the message into smaller chunks. So basically, let's say I would say the hey and the comma get stored into this one, right? And then what happens is there's, in simple terms, right? I want to make it this as simple as possible. I don't want to add extra terminology, right? So you might ask yourself, if I'm splitting this, okay, let me just split them up, right? I'm 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 gonna have quite a lot of packets, right? Just give me a minute while I put turn this into packets, right? So let's say the second one is how, right? And then the third one would be don't worry about how it's going to remember the order and the order and stuff. We'll get to that. So this will be remember it's how are you. So we need to have that order, and then we're gonna have this, right? And then how are you, right? And then the last one, I'll just combine it with the question mark. So just a simple example, nothing too fancy, so that we get to understand how the internet actually works, right? So right? So you have these chunks, right? Or these packets, or these blocks or pieces of data that need to be sent to that client. How would you facilitate that? How would you know the order? So there's the extra information that we need to add to each packet. So what I'm going to do is I'm going to do this. So just give me a minute. Let me do this. So just imagine just imagine this is like our cable, right? The tunnel or the cable, let's just say cable to make things simpler, because it does, let's think of this network as like a wired network, right? Remember, it's going to use electromagnetic waves to send the bits of data, right? So where's the part? Okay, yeah. So it's gonna use electromagnetic waves to send the data. So even wireless is fine, doesn't really matter. But yeah, let me use cable, right? So you can imagine this is the cable, and then this is the person's computer, right? They're typing it on some device. It could be a phone, it could be a laptop or a computer. But then just imagine this is a piece of it's hardware, right? And then this is hardware like a cable or a wire, coaxial cable or copper wire, whatever the wire is, right? And then there's chunks, right? So let me make it a bit longer. So this person must receive those packets, right? So this is going to be a very long diagram, but then I'll I'll share with you the image. So let me do this. Okay. So you might ask yourself, how will it know in what order to send these packets? So what happens is, first things first, they need to be divided into what we call packets, these messages, right? So let me do this. So we have what we call okay, let me not use server, right? Let me use simple names, right? Let me say check, check, and then nope. And then let's say this is Sarah, right? So Jack wants to send a message to Sarah. So this is how it's going to work. So Jack is going to type a message on his device. It could be computer or a laptop, any device. And then what happens is that message gets split up into what we call packets, right? So there's packets, or there's pieces or chunks of data. In order for us to know in what order to send these packets, you might ask yourself, how would you know, how would the computer know in what order to send the packets? So we have there's this thing that we have, right? each computer has what we call an IP address, right? Which basically it's something that tells it's like its name in a way to uniquely identify that computer, right? It's like this person is called Jack. I know because this name uniquely identifies that person as Jack, or ID number if you want it to be, I mean, we're referring to unique. Yeah, just think of a number. It could be a passport number or an ID number. So that's what we call an IP address. So I can even show you so that you don't think that I am lying. So I'm gonna type this command IP config, right? So there's my IP address. So this is what uniquely identifies my machine, right? Obviously, it's not wise to show people your IP address. I'm just doing this so that you get to understand what's really going on. We'll get to the IP address and how all these digits are generated and stuff. But yeah, so this is how this IP address, you can view it as like a an ID number. It uniquely identifies that object, right? In this case, the object is my computer or laptop. So I'm gonna copy that IP address. Don't have to, but so what happens is it in order for it to know who it's sending to, who's the sender and who's the recipient, it needs to the packet or each piece of data, it needs to have that piece of information that says this is from this person and it's going to this person, right? So I'm going to put it in simple terms and do this. And so it bundles it into one thing like this, right? So here would have, okay, here let me put the order, right? So remember, also need to have the order in which these packets are should be arranged when they go to that site. So let's just say this is the first piece of data, right? So that the computer knows when it's reordering the packets that side that, oh, okay, I should put this one goes first. So this is number one, this goes first, this piece of data goes first. And then, yeah, it's going to be quite a long. Okay, it doesn't want, don't know why it's doing that, but yeah, let me do this. So this would be hey, comma, right? And then remember that we also need to know who to send it to, right? So what I'm going to do is I'm also going to concatenate or combine that piece of data there at the end. So this is going to be that person's ID number. In this case, is the IP address, right? So that case, it's an IP address, which you can view in terms of like to uniquely identify the device over the internet, right? Over the internet. So you might ask yourself, what does IP stand for? IP just stands for Internet Protocol, right? And protocols are just, you see what protocols are. Protocols just tells the computer over the internet like what format the data should take. That's the main thing of protocols. So we're gonna need an IP address there. So let me just come up with some IP address, right? So let me just say, uh, so remember your IP address is gonna be different because you're not connected to the same router as I am connected to. So don't expect this, and it should be unique. Remember, it uniquely identifies the device over the internet. So I don't know why it's not allowing me. Okay. So let's say 1, 2, 3, keeping it simple. And just remember that in an IP address, I know I'm adding a lot of information, but then in an IP address, right, there's 4 digits. Hey, damn, that's a lot. So there's 4 digits, right? It's 4 digits. There's IPv4, right? Basically means 4 digits to uniquely identify the laptop. And these 4 digits are separated by a dot, right? And then each digit is in the range, is between 0 and 255, right? So that's why you see these digits 193, 123. The maximum is 255. You can sort of think of it in computer science 1B when you did pixels. 0 meaning the minimum, and then the minimum intensity, and then 255 maximum intensity. But in this case, we're just viewing them as literal digits, as numbers. But then it's something like that. So each digit, and then an example, right, would be like this. An example would be 123.3.7.9 or 200, something like this. This would be an IP address, IPv4, which is Internet Protocol version 4, meaning that there's 4 digits to uniquely identify to generate that IP address, right? Which uniquely identifies the device over the internet. So we have that out of the way. We understand what's going on now. So remember what I said, when the data is transmitted, it gets split up or divided or cut into smaller pieces, like on the pieces on a when you cut when you cut your pizza, you cut it into pieces, right? And then you give each person their portion, right? So it's sort of like that. We cut it into the data itself is cut into different pieces. And then we add all these pieces of information so that the computer can process, so that the computer can sort of like process things in its own way, right? So, okay, I'm gonna need to make copies of those. So I need okay, this is no longer needed. This is no longer needed. How are you doing, right? I don't think I also need any of those now. So here I just put R, simple. So I don't need all of this now because I'm just gonna copy and paste that. But then you understand that everything is divided into chunks or packets. The right terminology for it is called packets. So so here, so how are you? And then this one will be 2, this one will be 3, right? So remember, the number tells the computer, okay, this is the first one, and this is the second one, because okay, we'll get to what's going to happen, why this numbering is important. So this would be the fourth one. So how are you doing, right? Like this. And then, okay, let me sort of like put it in the middle. Yeah, put it there and then do this. So this is the message that Jack wants to send to Sarah over the internet, right? Mm, okay, that doesn't matter. Let me not put that. So what happens is these pieces of data, they get cut into, they get divided into what we call packets or chunks, which is just smaller pieces of oh, just smaller pieces of the bigger piece, right? At the end of the day, we have that one large big piece of pizza, but then we need to cut it into smaller pieces. So what happens is when we have this data, right? There's our data. Hey, how are, okay, there's something missing. How? I forgot how. So let me add that. It actually doesn't matter in what way I order them. So how, this would be the second one. And then this would be the third. fourth, and then the fifth, right? So it doesn't matter in what order I arrange them, because the number will tell the computer in what order should you arrange them when they get to the client or the person who's receiving the information, right? So I need to also connect this there. Okay. Since there's a lot going on now, so let me delete this and then add it again. Yeah, there's quite a lot going on when you send messages. You just haven't thought about it, but yeah, there's quite a lot. The computer is humanity's friend, because it does a lot for us behind the scenes that we don't even think about. But then since you're a computer science major, you have, even if you're not a major, as long as you're doing computer science 2B, you need to understand how it works. So they are divided into what are called packets, right? So each packet is that piece of data. This would represent from, where is it? It's coming from whom, and then to where is it going to, right? So this would be like this. You will get to the actual under the hood how it looks, but then just view it in this way. So this is from. This just tells it it's from this person, so that the computer knows where is it coming from, and then to, so that it knows who to send it to, right? So I'm going to choose a different color. Let's be bold. Let's choose pink. So I'll choose pink. So there we go. So then you can imagine all the other parts. It's from, to, but then I know people tend to forget these things. So let me just add it. When you look at the diagram, you might forget and be like, what was going on again? And then now you have to contact me and ask me what was going on. So it's gonna be like this. There we go. So from and to, right? So let me also copy to, because it needs to know where that message is coming from and where the message is going to. So that's very important information for the computer to know. That's why it's always going to be in this format. So we have to, from, and to, right? And then this is a message. This is the thing that uniquely identifies it, right? So what happens is each of these packets, right? Each of these pieces of data, right? They travel independently through the cables, right? Independently. This one will travel through this wire. Come on. Copy. And then this one will travel through this. This one will travel through that. So let me do this. Let me align it. All right. And then this one will travel through this. And then the last one will travel through its own, sort of like its own tunnel, right? It travels through its own tunnel, which is going to be the wire or the cable, right? And remember, it uses electromagnetic waves. So we have this, they travels through there. They're all traveling independently. They don't know about each other. They don't have to know about each other, because the pieces of information that are important is the number. In what order should you arrange them when they are received by the client, right? So this is the system, right? And then when it's received by this client, this side, right? Remember, it's going to be received as it in the same order it was that side when it was sent. So I'm gonna go this side, and then we're gonna have the pieces of data now. So there they are. So this would be the first one, like this, right? And then it has reached the other side, right? It has reached the client. the person who's supposed to receive the message, right? And then copy. And remember, the order doesn't matter because at the end of the day, we know the computer knows which one comes first and which one comes last. So there we go. And then I'm gonna copy this, copy, and then go this side. There we go. And then, come on. And then that's the message that we received through that wire, or that you can view it as a tunnel, doesn't matter. But then these are actual wires. And then there we go. And then this was received through that wire. Come on. There we go. So we have that message over there. And then there we come on. Why is it not selecting anymore? So just give me a sec. I'm still trying to select it. Okay. There we go. And then that's the last packet there, right? And then now comes the assembling part, right? So let us assemble it, bring it together, right? Put it together, right? So let's do that. And in order for the computer to put it together, it needs to know the numbers and who is it sending it to. So this would be Sarah, right? So Sarah, come on. So let me copy this. So this would be this would be how the computer identifies Sarah, right? So I'm gonna put the IP address here. They say this is Sarah's, come on. So 192.168.1.123. So this would be Sarah's IP address, right? So that it knows, oh, so I need to send it to Sarah, or that computer with that IP address. So that's why I said it's important to know the from and to, right? So let me do this. Okay, I'm gonna take a bit of time doing this, but just bear with me. I was supposed to copy everything, but then it's okay. We have time because it's important to understand what's really going on. Because if you fail to understand what's really going on when it comes to programming, it's gonna be it's gonna be a nightmare. It's gonna be like watching the most scariest horror movie you've ever watched and not being able to finish that horror movie. So just be careful with trying to skip and fast forward. Because if you skip and fast forward, they'll also skip and fast forward your marks. So just keep that in mind. So I'm gonna put 2 there. I'm just putting it this way so that you can think about it and visually see how it works so that you understand. So and then now it comes to the assembling part, right? So bringing the message together, bring it together, right? So let me put Sarah that side. Let me shift Sarah a bit to that side, right? So there's the message. So the order matters, right? That number matters. So it's gonna put um the packets together, right? In that order. So the first one, number one is this one, right? So one. So I'm gonna put the number in the message. So hey, comma. So this would be the first packet, right? And then let's choose a different color. So let's choose this one. Let me see. Should I make this one blue? Yeah. So let's choose this color and then copy, paste. And then this would be the second one. What's the second packet, right? It's how, right? So it's going to be how, and then done. And then the third one is going to be what? How are you? So number 3 is you. And then it's going to bring them together like this. So I'm going to put them together like that so that you can actually see it. Yeah, I'm putting a lot of effort to trying to make sure you can visualize it. So you, because I really want you to understand what's going on, don't just be taking chances and be like, oh, I think I kind of do get it. No, you should get it. Don't kind of get it. So I'm gonna have, how are you? Oh, okay. How are you doing? Wait, let me see. Hey is number 1. Number 2 is how. Are is 3. Okay, so number 3 is wrong. I'm supposed to say are. So this should be are. So how are you doing? Then there's the last packet today, which is number 5, right? Doing. So this would be the overall message, right? So that's the overall message in that order with the specific numbers. So once it has those specific numbers, right, it gets assembled in the order, right? Starting from the number 1 up until the last one. So this is in general exactly how it works for anything that you're sending on the internet. Anything that you're sending on the internet, this is how it works. It needs to know the to and from IP addresses are needed. So it assembles, and then you have that. And then I'm just going to put one last step. So let's just remove the numbers because obviously Sarah won't get the message with those exact numbers, right? So I'm going to do this and write the message in full, right? So this would be the message. So this would now be the message. Hey, how are you doing? Right? So this would be the overall message. There we go. There we go. So this would be the overall message. And then I would go back that side and then copy. And then this would be Jack's IP address, right? Because I need to also put it there so that you don't forget what IP address means. It just uniquely identifies that is that laptop, that device on the internet. Okay, so that's pretty much it. So this is the whole flow. So you can imagine this is your coaxial cable or copper wire. So this is the wires, right? So this will be the wires. So let me enlarge the text. So this would be wires or cable. So that'll be the wires and cables. And then style, let's use, okay, this is, I've used it too much. Yeah, let's use the same color. So that's the wires or cables. And then remember they use electromagnetic waves if it's wired. So we have that, it's sending, and then it assembles the pieces of data together to overall give Sarah that message. So now I'm gonna save this. Okay, so let me say export as PNG. appearance dark, right? So let me just export, and then let me say computer networking, right? And then I'm gonna save. I want to see if it does show. Okay, very good. So you can see, you can just zoom in and see the diagram, right? So this is exactly how it works. So I'll also upload the PNGs so that you can see it. So we have a bit of an understanding of how it works, right? So yeah. So the transmission rate is the rate at which the data is being transmitted. But remember, it's going to use electromagnetic waves. At which rate is it sending? As you can see, the exact diagram that I made, it's in packets or smaller pieces, and then they are assembled together like this, and then they are forwarded to that user in the right order. And remember, they travel independently. So let's think about let's look at packet switches, right? So packet switches are responsible for sending and receiving packets via communication links, right? So communication links, you can also view them as like roads, right? So communication links are roads, and then your end systems or the hosts would call, you can view that as a building. So imagine you have, let me make an example. Let's say you have a company that delivers, let's say you want to deliver something, right? So you have a lot of clothes, right? Let's say you have a lot of clothes, right? And then you divide the clothes into each box, right? You put clothes in each box or a packet, right? And then each box is labeled, is written the name and everything, and then it gets added into the trucks, right? It gets added into the trucks. So the trucks in this case, we can view them as, I think, can view them as routers, right? So the trucks, it takes the data, right? And then the trucks, the data where you're taking it from, right? The building where you're taking the clothes from, would call that the computer, right? That's the host. That's the end system, that building. And then those boxes would be the packets, right? And then these cars will travel, these trucks will travel on roads, right? Or communication links, right? And then packet switches, we can view them as like on those roads, when you see intersections, that's what we would call packet switches, right? There are two most common packet switches, namely routers and link layer switches, right? So yeah, these are the two types of packet switches. We have what we call a router or a link layer switch. When a packet is sent from one end system to another, it travels to what we call a path or route. So that communication link, right, or that road, it's called a communication link in the computer networking terminology. You can also call it a route or a path. Still the same thing. So there's an example. You're packaging you're adding your packets into the truck, and then they're going to be transmitted via the communication links or roads, and then they eventually get to the endpoint, right? So you might ask yourself, how do the end systems access the internet? So they access the internet through what we call ISPs, which is internet service providers. Some examples of ISPs are, you can view them as MTN, Telkom, and Vodacom. Internet service providers, a company or someone who provides internet service, right? Hence, internet service provider. End systems, they run protocols to control the sending and receiving of packets, right? They run what we call protocols. So transmission control protocol, TCP, and internet control protocol are the two most fundamental or common protocols in the internet. And then IP protocol specifies the format of the packet, right? So the IP protocol specifies the format of the packet. So almost at the end, so there's many protocols, right? So each protocol sort of like tells what format and rules to use when sending this data. We have what we call, let me make simple example. We have what we call FTP, right? So it's a file transfer protocol, right? So this is a rule of a protocol that tells the computer that the computer uses when it's sending what files over the internet. It uses what we call an FTP protocol or file transfer protocol. Then there's a SMTP, which is for Gmail, simple mail transfer protocol, which is a protocol that gets used when you're sending an email to someone. And then the last one is HTTP, this stands for hypertext transfer. Yeah, it's hypertext transfer protocol, right? So this is usually for web web servers, right? Basically websites. When you're dealing with websites, it uses what I call an HTTP protocol. So this is for email, right? And then this is for sending and receiving files. That's the protocol that gets used, receiving files, right? So these are the different protocols that the computer uses. So let me show you a simple HTTP protocol, right? So let's say HTTPS, right? And say www.uj.ac.za, right? So as you can see, I'm using a protocol. So let me go up. So as you can see, I'm using a protocol, right? HTTP. So this is HTTPS, S standing for secure, meaning that's the security added to that protocol, right? So it's still HTTP. I could just use HTTP, which is the unsecure one, but then it's still the same thing. So I'm using HTTP and I'm telling the computer over the internet that, listen here, access this web page on a web server. So web server is basically where all the web pages on a computer, the web you see when you run a website, right? It's full of pages and files and images. Where are those things stored? They are stored on what we call a web server. So it goes to this protocol, tells the computer to go to this URL, right? Um, I think it's called Uniform Resource Locator URL. So it goes to that address, right? But then remember, at the end of the day, this is just a simpler way of accessing UJ, right? It's good. Remember, human beings are very bad with numbers. But then under the hood, it's actually using what I call an IP address. So the computer uses what it's used to. So it changes this to, let's say 1, 2, yeah, let me say localhost, right? So 127.0.0.1, right? It translates it to something like that. It's just that it's easier to recall www.uj.ac.za than remembering the actual digits and numbers that are involved. So this would be the easier way. But I just wanted to show you the example of a protocol. This is an HTTP protocol, which is used to retrieve websites or web pages from the web server, right? Which web server you can imagine is just where you store your fancy. It's a fancy name for where the pages are stored, right? So you can imagine, remember that a website is like pages of a book. You can open the first page and then go to the next page, go to the next page, or let's imagine a textbook. You can open a textbook, right? And then see the first page, which is it shows you the number of pages involved. There's an introduction and stuff like that. So where can you store your book? You can store your book inside a school bag or inside your wardrobe, anywhere, or the bookshelf. So that where you are storing your book or those pages, it's what we call a web server. In this case, it's on the internet, so we call it a web server since we're dealing with the web. with the World Wide Web, WWW, right? World Wide Web. So that's just one of the protocols that we use. So we're almost done. So when it comes to these protocols, right? You might ask yourself, why was there need for protocols to be added? So protocols just help create what we call a standard, right? So what do I mean by standard? So imagine if there was no universal rule that imagine that there was no universal rule that a let me think, a sentence, right? So a sentence is supposed to start with an uppercase letter and end with a period or a dot. So let's say a simple sentence, right? I am going to school, and then a period or a dot. If this is what we call this in this case, I'm following what we call a standard, which is a universal law or a universal rule, so that everyone, no matter where in which country you are, the format and the way you write the things is going to be exactly the same. So that's why we need standards, because someone in some other country might say, you know what, I don't feel like putting the first letter up, capitalizing the first letter. I'm gonna use a small letter. And then for the rest, I'm gonna use uppercase letters. And then I'm just gonna play around and then put a T and then O and then put small and then C and then double and then small. And then I don't even put a dot, I put a comma. So now it becomes very confusing, because that means every time when you're about to read anything sent from another person, they must send you a long PDF explaining their own rules on how they construct sentences, which becomes a problem. So we need a universal rule that forces everyone to use that same universal law. So let's view it in this way. Let's say in some other countries they used SMTP for getting web pages. So you see, it becomes very confusing. We can't all come to an agreement if everyone is free to use any to rewrite the rules, right? So that we need what we call standards, which is like a universal law, a universal rule. Just like, for example, when you write your Java code, it needs to be of a specific standard so that other Java developers worldwide, they can immediately understand what your code is trying to say, which when you're trying to understand the code, the meaning of the code, we call that semantics, right? So you're gonna look at the semantics of the code and try to understand what it's saying, right? And it's easier to look at this semantics of the code if you're following the Java standards. So that's why here I said Java internet standards are similar to standards like C++ standard and Java's language specification, right? Which just states how we should write C++ code and how we should write or format Java code, right? So this ensures that everything on the internet is done in such a manner. I made a mistake. In such a manner that it is consistent throughout the world, no matter where you are. And these standards are developed by what I call the Internet Engineering Task Force, IETF. So that's mainly what those standards are for, just so that we can universally write the same thing, or the same or everything that we write, it universally has the same meaning. Back in the days when languages like C++ and Java, okay, C++ when they were made, and C, you it would differ from compiler vendor from one compiler vendor to another compiler vendor. So since there was no standard, there was no universal rule or law that states no, every C code needs to be formatted in this way. There was no there was no standard yet. So people just write their own way. I can write my if statement in this way, I can invent my own things, and it becomes very cumbersome. It becomes problematic and hard to understand. And you tend to not get to a common common we tend not to reach common ground if what I'm saying cannot be easily translated to your way or your language, right? So standards are very important because they define the universal law of how you should write everything. So when it comes to internet, the Internet Engineering Task Force is responsible for that. So that's pretty much it, the introduction. So thank you. I'll see you in the next lecture. Right? So I'll upload the material that I was using. Yeah, I'll upload everything. See you in the next video.